Math with Mr. Williams, Example 1, Finding the Mean, the Average. The table shows the numbers of text messages sent by a group of friends over 1 week. What is the mean number of messages sent? So we have a couple choices, 100, 102, 103, and 104. So if we look over the text messages, we see there are going to be 7 of them. And each person has a different number. So what we're going to do is we're going to add all those up. So we're going to write 120 plus 95 plus 101 plus 125 plus 82 plus 108 plus 90. All right, so let's break out our calculator. So we have 120 plus 95 plus 101 plus 125 plus 82 plus 108 plus 90. Hit the equal. We end up with 721. Okay, now what we're going to do is we're going to divide by the number of data values. So we see that there are 7, so we're going to divide by 7 to find our mean. So we bring our calculator back, we type in 721, and we divide it by 7. And that gives us 103. So the mean number of text messages sent is 103. So the correct answer is C. Math with Mr. Williams, Example 2, Comparing Means. The double bar graph shows the monthly rainfall amounts for 2 cities over a 6-month period. Compare the mean monthly rainfalls. So we have City A versus City B. We can see it goes by months, November through April. And so let's go ahead and find the mean for just City A. So what we're going to do now is we're going to highlight just City A, and that's the darker green sections. All right, and now we're going to add them all up. So we have 3.5 plus 2.2 plus 1.9 plus 2.1 plus 2.5 plus 3.4. All right, let's go ahead and add those up. So let's bring out our calculator. So we have 3.5 plus 2.2 plus 1.9 plus 2.1 plus 2.5 plus 3.4. That gives us 15.6. So we add all that up, we end up with 15.6 so far. All right, and so how many numbers did we start off with? We see there is 1, 2, 3, 4, 5, 6 months here. So we're going to divide by 6. So pull our calculator back out. So we have 15.6 divided by 6, giving us 2.6 for City A. All right, on to City B. So we identify all the numbers we're going to use. We're going to add them all up. So we have 1.7 plus 1.6 plus 2.2 plus 2.1 plus 2.7 plus 1.7. So let's go ahead and break out our calculator. So we have 1.7 plus 1.6 plus 2.2 plus 2.1 plus 2.7 plus 1.7, giving us 12. Now, same 6, so 12 divided by 6 will give us 2 for our mean for the City B. All right, so because 2.6 is greater than 2, City A averaged more rainfall during the time period. Mr. Williams, Example 3, Finding the median and mode. Find the median and mode of the bowling scores. So they gave us a table, and I'm going to take all those scores, and I'm going to put them in order from least to greatest. So the first number I see would be 90. I'm going to cross it out. The next number 105. The next number would be 120. The next number would be 125, followed by 135, then 145, followed by 160, and another 160, then 175, and lastly 205. That puts our numbers in order from least to greatest. All right, so to find the median, we put our numbers in order from least to greatest. Now we're going to find the one in the middle. So the problem is that there are an even number of values. There are 10 of them. So we need to cross them out and find the ones in the middle. Because when there are an even number of values, you find the 2 in the middle and you find the mean of those. So let's go ahead and find the 2 in the middle. So we know that there's 10. So let's go ahead and find the first 4 on either side. 1, 2, 3, 4. 1, 2, 3, 4. And here are 2 numbers in the middle. Now to find that median, all we're going to do is add these up and divide by 2 to find the mean between them, or that middle number. So 135 plus 145 will give us 280. We're going to divide that by 2, giving us 140 for our median. All right, on to the mode. All right, for the mode, we already have our numbers in order. Now we can quickly see which one happens the most. So we see that there's only one of every number except for 160. So 160 represents the mode because it occurs the most often. So the median is 140 and the mode is 160. Math with Mr. Williams, example 4. Finding the mode. The list shows the favorite types of movies for students in a class. Organize the data in a table, then find the mode. Okay, so here we have the type, action, comedy, drama, horror, and we need to count out how many students voted for each one. So let's go through and do action first. So we see we have 1, 2, 3, 4, 5. So we have 5 students that voted for action. Now comedy. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 comedies. And how many dramas? 1, 2, 3, 4. 4 dramas. And now on to horror. So we have 1, 2, 3, 4, 5, 6, 7. 7 students voted for horror. And we know for the mode is the number that happens the most often or most frequently. So in this case, most of the students voted for a comedy, so our mode will be comedy with 8. Math with Mr. Williams, example 5. Climbing shoes. Use the data to answer the statistical question. How much do climbing shoes cost? Find the mean, median, and mode of the data. Then answer the question by determining which measure best represents the data. All right, since we're looking for the mean, median, and mode, I like to start with the median because that forces me to put the numbers in order from least to greatest. So let's go ahead and look at our climbing shoes, and we see that the smallest number we have up here is 40. All right, and then we find, oh, we have another 40. And then we have a 51, followed by 57. Then we have a 65, and a 68, an 85, and finally 142. So I see there are 8 values, so I need to find the one in the middle. So I see that these two, 57 and 65, will be in the middle, so I add them up, 57 plus 65, and I divide them by 2 to find our median. Let's pull out the calculator. So 57 plus 65 equals 122. We divide that by 2. And we arrive at 61 for our median. So for the mean, all I need to do is add up all the numbers that I just put in order. So I have 40, 40, 51, 57, 65, 68, 85, 142, all added up. Let's go ahead and do that with our calculator. So we start off with 40 plus 40 plus 51 plus 57 plus 65 plus 68 plus 85 plus 142. That'll give me a total of 548. Now I need to divide that by how many values we had. So we had a total of 8 values. So I go back to my calculator. We type in 548 and we divide that by 8, giving us our mean of 68.5. And since we're talking money, we'll make it 50 cents. So $68.50, and we'll go back to that 61. Let's change that to money too. $61. And now let's find the mode. Which one actually happened the most? So I can see the mode here. Since we have two 40s, the mode should be 40 because it is the number that occurs most often. So $40 would be our mode. All right, so we have our mode of 40, and we have 68.5 for this number. All right, we change them all to money. Okay, so we found the mean, median, and mode. Now, which measure best represents the data? So the mode is this lesser end of our data, and now we look for that median is 68.5, so he's right around this area. And then we have our median at 61. So the one that seems to be in the middle of most of the data is going to be our median. So that is the best representation of our data. So $61. Math with Mr. Williams, example 6. Finding the range. The table shows the lengths of several Burmese pythons captured for his study. Find and interpret the range of the lengths. Okay, so first thing you want to do is order our numbers from least to the greatest values. So let's go ahead and do that. So we have 5, we have a 6.25, we have an 8, we have a 10, then we have an 11, then we have a 12.5, then we have a 14, then we have a 15.5, then we have a 16 and a quarter, and then lastly we have an 18.5. Okay, now that we put our numbers in order from least to greatest, we need to find the difference between the greatest value and the least value. So here is our least value, and here is our greatest value. So difference means to subtract them, so we're going to take 18.5 and we're going to subtract 5 from it. And 18.5 minus 5 will get us 13.5. We're going to label it as feet. So the range of lengths is 18.5 minus 5, giving us 13.5 feet. That means that the lengths vary by no more than 13.5 feet. Math with Mr. Williams, example 7, finding the interquartile range. The dot plot shows the top speeds of 12 sports cars. Find and interpret the interquartile range of the data. Okay, so the first thing we want to do is we want to order the speeds from the slowest to the fastest. So let's go ahead and do that. So we have 220. We have a couple 230s. We have a couple 240s. We have a 245. We have three 250s. We have two 260s and one 270. So now we have to find our median. So we find the 2 in the middle since we have an even set here. And we know that the number in the middle will be this one right here. We add these two numbers up and divide by 2. So we have 245 plus 250 divided by 2. So let's use our calculator. So we have 245 plus 250, giving us 495. We're going to divide that by 2, giving us our median of 247.5. So for the first quartile, we need to find the middle number or the median of the first half of the numbers. So these numbers right here. So the middle number will be between 230 and 240. So we need to add these up and divide by 2. Let's use our calculator. Add those up, it equals 470, and we divide by 2, 235. This would be for our quartile 1. All right, and then let's go to the third quartile. Let's find it. So we know it's the last half the numbers. We're looking for the median there. It'll be between 250 and 260. So let's add those up and divide by 2. Let's break our calculator out. All right, we get 510. Now let's divide that by 2. And 255 is for our third quartile. All right, and to find the interquartile range, we subtract Q3 minus Q1. So then we have 255 minus 235. We will arrive at 20. This means that the middle half of the speeds vary by no more than 20 miles per hour.